Hi students, welcome to Sunil's tutorial. I'm Sunil Milwani and today we'll be doing this chapter called as network analysis. Right? Now, let's see a sum. We want to do question number 3 on page 370. Activity A, B, C, D, E, F, G, H. Preceding activity. Preceding activity is A, C, D, D, C, E, F. Time in days. You have 3 times. You will do optimistic time, most likely time, and pessimistic time. Right? You have 2, 3, 10 for activity A, 4, 6, 14, 2, 4, 12, next 3, 5, 13, 2, 3, 10, 1, 2, 9, 1, 2, 3, and 1, 2, 3. These are the timing given to you. Now the first thing that you have to do, they've given me 3 different times. They've given me optimistic, most likely, and pessimistic time. That means first thing I have to do is make a time estimate table. So first thing I'll do is make a time estimate table. Activity A, B, C, D, E, F, G, H. Right? Expected time TE is optimistic time plus 4 times most likely times plus pessimistic time divided by 6. So let's see this. Now for activity A, it is going to be equal to 2 plus 4 into 3 plus 10 divided by 6. When you solve this, you should get this as 4 days. For activity B, it is going to be 2 plus 4 into 6 plus 14 upon 6. When you solve this, you will get this as 7. For activity C, it is going to be 2 plus 4 into 4 plus 12 upon 6. When you solve this, you will get this as 5. For activity D, it is 3 plus 5 into 4 into 13, plus 13 divided by 6, right, which works out to 6, yes. Next, let's see the next one, guys. For activity E, it is going to be equal to 2 plus 4 into 3 plus 10 divided by 6, which will work out to 4. For activity F, it is going to be 1 plus 4 into 2 plus 9 divided by 6, which will work out to 3. For activity G, it is going to be 1 plus 4 into 2 plus 3 upon 6, which will work out to 2. And finally, for activity H, 1 plus 4 into 2 plus 3 upon 6, which will work out to 2. So now I have got my estimated time. Once I have my estimated time, then I will find out my variance. Variance is given by the formula B minus A the whole square divided by 36. Right? Do we get this thing clear? So in that case, this is going to be equal to B minus A, 10 minus 2, 8. 8 the whole square is 64 divided by 36. 14 minus 4, 10 the whole square, 100 upon 36. 12 minus 2, 10 the whole square, 100 upon 36. 13 minus 3, 100 upon 36. 10 minus 2, 64 upon 36. 9 minus 1, 64 upon 36. 3 minus 1, 2, 4 upon 36, and 2, so 4 upon 36. Once my variance is done, the next thing that I have to do is I have to make network diagram. Let's make network diagram. It starts with event 1. Now you have nothing preceding A, so A goes to B. You have event A, that will go to 2. The time for this is going to be 4 days. Now from A you have B, from A you have C. From A you have B, and from A you have C. B is 7 days, C is 5 days. That will give me event 3 and event 4. Right? Then from C you have D. Right? From C you have D, and from B also you have D. B and D combine to give you, B gives you E. B and D combines to give you E. So that means this arrowhead should be this way. So from C you have D, whose time is going to be 6 hours. Right? From C you have D. Now B and D combine to give you E. Okay. So in that case this is going to be 5. Once you have this, from C you also have F. E was 4 days, F is 3 days. 6. Right? Once you have that, then you have from E and H. From E you have G, which is going to be 2 days. From F you have H, which is 2 days. So this is 7. That's my network diagram ready. Now let us see what are the various paths I can have. Paths. I want to go from 1 to 7. So you will have A, B, E, G. That will be one path. Then you will have A, C, D, E, G. That's another path. Then you will have A, C, F, H. That's another path. So those are the 3 paths that I'm going to have. Duration. A, B, E, G. That's 4 plus 7 plus 4 plus 2. Right? So that is going to be 17 days. Now I have A, C, D, E, G. A, 4 plus 5 plus 6 plus 4 plus 2, 21. Which is 21 days. And then you have A, C, F, H, which is going to be 4 plus 5 plus 3 plus 2, which is 14 days. So those are my durations. Once I have my durations, the next thing that I have to do is I need to find out the critical path. So I can say that D, critical path. The path that takes maximum time is called as the critical path. So my critical path is ACDEG. ACDEG. That's my critical path. Normal project completion time. Normal project completion time is 21 days. Okay, and let's find out the variance. Variance I need for ACDEG. For A it is 64 upon 36. For C it is 100 upon 36. For D it is 100 upon 36. For E it is 64 upon 36. For G it is 4 upon 36. Right? So when you work all this out, you should get your variance as 200 to 328, and this is 332. 332 upon 36. Right? So in that case, that will come out to 332 upon 36 is 9.22. Once I get variance, the next thing I need to do is find out standard deviation. Standard deviation is square root of variance, which is going to be square root of 9.22. Right? which will work out to 3.04. So in PERT analysis, the first thing that you have to do, irrespective of whatever the question is, you need to make a time estimate table, a network table, and your conclusions from that. Now, you start reading the question. What is the probability of project completed? Project completed in 24 days. Right? For that, I need to first find out the normal variable z. Right? Normal variable z is given by the formula due date minus expected date upon standard deviation. Due date is 24 days. Expected days. My normal project completion time is my expected days. 21 upon 3.04. So when you work this out, this is going to come out to 0.99. Right? Now, guys, let's draw the bell curve. This is going to be 21 days, the center line. I want 24 days. The z, this point here on the curve we found out is 0.99. We know that half the area of the bell curve, this half of the area is 0.5. Now I need to find out area. Guys, when you are looking at your normal probability distribution table, there are two things that you are going to have, guys. I'll show you the table. You have two columns here, you have columns here, and you have numbers here. When you have to find out the area, you look at these columns. Guys, when you have to find out the area, for that you look at these columns. When the area is given, you look at here, the numbers that are given to you. Now in this case, I need to find the area. 0.99. 0.99.
3621.
3389. 0.3389. Right, this area is 0.3389. Right, once I have this, then I can say therefore that probability of project being completed in 21 days, no, not 21, 24 days is 0.5 plus 0.3389. So that's 0.8389. That's the probability that the project will be completed in 24 days. Simple, straightforward. Next, probability that project completed in 19 days. So in that case, let's find out your normal distribution.
You have to find out z every time.
Yes. Every time you change the number of days, you find out z. Right? Z is due date minus expected date upon standard deviation. That's 19 minus expected date. 21 upon standard deviation. That is 3.04. So when you work this out, 0.66. The negative sign is of no meaning here. It only indicates that my line is going to be on the left hand side. So let's see the normal curve. That's my bell curve. My central line is going to be 21 days. Right? I want to find out for 19 days. This area will be given to me in the curve. This total area is 0.5. Okay. Now this area is given to you in the normal distribution table, 0.66.
That is 2454.
How do you know
Yeah,
0.66?
We didn't
Oh,
have
yeah, sorry.
Right? 0.66 is going to be
2454.
2454. 0.2454. Right? So in that case, what will be this area? My probability of 19 days is going to be equal to 0.5 minus 0.2454. Someone do the subtraction. How much is this?
0.2546.
0.2546. Right? Next, the next part of the question. What is the probability that the project will not be completed in 22 days? When they say not, you say completed. So project completed in 22 days. What's the probability of project being completed in 22 days? Again, like you asked me, you have to find the new normal distribution variable z, that is due date minus expected date upon standard deviation. Due date is 22, expected date is 21 upon standard deviation. Standard deviation is 3.04. Right? When you work this out, this should come to 0.33. So let's draw the bell curve for this. Yeah, you want to ask me something? 0.33. The bell curve for this is going to be this way. This is my center line, which is 21 days. I want 22 days. Right? So that means now this area I already know is 0.5. I want to find out this area. Right? Now, this variable z you have found out as this point z is 0.33. Someone tell me how much is it?
1293. 0.1293.
0.1293. Right? So in that case, probability that the project completed in 22 days is going to be 0.5 plus 0.1293. So that is 0.6293. So, but they haven't asked me that the probability of project being completed in 22 days. So what is the probability that project not completed in 22 days? Completed in 22 days. Project not completed in 22 days is 1 minus project completed in 22 days. Not is always 1 minus completed. Not completed is 1 minus completed. Not completed is 1 minus completed. So this is going to be 1 minus 0.6293. So this is 707. 3707. That's the probability that the project will not be completed in 22 days. Right? Now, the company has to pay a penalty of 5,000 per day for late completion of project. What is the probability that the company will pay a penalty of not more than 10,000 rupees? Now this should be interesting. Penalty of not more than 10,000 rupees. Now guys, the penalty is 5,000 rupees per day. That means for 10,000 rupees, I should be paying a penalty of for 2 days. So penalty of 10,000 rupees corresponds to 2 days. Right? That means if my probability that the project should be completed in 2 days beyond my normal expected days, so in that case my due date will be 21 days the project should have been completed. Since I am paying a penalty means I have taken extra time. How much extra time? 2 days. So 23 days. That means what effectively they have asked you to find out is that the probability of the project being completed in 23 days. They just twisted the question and asked you this. So now I can find out z. Z is equal to due date minus expected date upon standard deviation. That's 23 minus 21 upon standard deviation. We found out as 3.04. So when you work this out, this should come to 0.66. I presume we've already found this out for 0.66, but we found it out the other way. This is going to be my 21 days. This is 23 days. This variable z here is 0.66. This area here is 0.5. Someone please get me this area. This area is
2454.
Yes, 2454. Right? So in that case, I can therefore say that the probability that the project is completed in 23 days is going to be 0.5 plus 0.2454. That's 0.7454. This is the probability that the project will be completed in these many days. So the probability that penalty will not be more than probability that penalty is not more than 10,000 rupees is 0.7454. Next part of the question they've asked you, the company will pay a penalty of more than 10,000 rupees. Now this is my penalty, this is the probability that it will pay less than 10,000 rupees. So probability that penalty is more than 10,000 rupees is going to be 1 minus less than 10,000 rupees, that's 7454, that's 6452. Probability that the company will pay a penalty of more than 10,000 rupees is going to be 0.2546. Fine? Do we get this thing clear? This finishes the sum. We'll stop this here for the day. Thank you very much.